Hello everyone, welcome back to my channel.
In this video, we will analyze the merge sort.
So what is the time complexity of the merge sort? We
Cannot use the same method to analyze step by step as insertion sort. Instead, we need to construct a tree structure to analyze the steps because it involves divide and conquer and recursion.
let's check the best case. Assume the best case here have a cost of C1 constant for each step. And for the divide and merge part, so divide and merge have a constant time C2 when you run each divide. Okay, so if the P larger or equal to R, which means there is a single element for the array, which means the n equal to 1, it will have the constant time C1, right? What if we have n elements? In the top level, we have n element, right? And we need to divide then into n divided by 2 element. And then we divide by n divided by 4 element. And then we'll go all the way to single element here. So for each single element, we do the C1. So we have C1. Not only 4, maybe a lot of C1 here, depending on the size of the array. Like here have an element. So in the tree structure, once it reaches to end, it will calculate the runtime. So at the end, we have the how many times for this instruction is C multiplied by n. Right? And go back for each divide part, we have C2 multiplied by n. C2. Why is C2 multiplied by n? Because there are 4 elements. Like each element you have n divided by 4 times operation. So till the top is C2 multiplied by n. And then we know each level we have a linear time here. And for the from the top to bottom, how many level we have? So this is solving a 2 to the power of x or equal to n. Because we have 1, right? And the 1 of 2, 1 of 4, 1 of 8. This is the 2 to the power of x. So the x will equal to log n with 2 base 2. Okay, so for each level, so for each tree, we have log n time complexity and multiply by the each level we have n. So this value is the time complexity of merge sort. I'll talk about more theorem about how we get this one, but the general idea is when you use divide conquer, you usually will construct a tree-like structure, and for the tree-like structure, usually it is log n time. So in this case, actually it's log n plus 1. So this one is another level. And this part is log n times. And then we got the algorithm merge sort has the time complexity as n log n, right? And this one will be better than the insertion sort in the worst case. So in the worst case, the insertion sort has n squared. This time is larger than this time. So the log n is slightly smaller than n. So we can see the merge sort is a little bit more efficient than the insertion sort in the worst case. Thank you.